Okay, this is MYP2 Unit 4. It's an algebra unit. There are all the factual, conceptual, debatable questions. We'll talk more about those in class at some stage. But this video is just to run through the notes. So a little contents list there. You can pause the screen to write that down if you missed it in class for some reason. So recapping something we did in MYP1. Chapter 1, Solving Equations. The idea of balance is crucial to solving equations. Whatever we do to one side of an equation, we must do exactly the same to the other side. So here I've got 3x plus 4 equals 10. So I'm trying to get the bit with the x on its own, so I've taken away the 4. But because I've taken away 4 on the left, I have to also take away 4 on the right in order to maintain the balance. So minus 4 both sides. And I like to write it on the side like that. So I've got 3x equals 6. I don't want to know what 3x's are. I want to know what 1x is on its own. So I divide everything by 3 to get a single x. But because an equation is like a balance, whatever I do on one side, I have to do exactly the same on the other side. So I've divided the right and the left-hand side by 3 to get x equals 2. Then there were some questions from the book, page 184, exercise 9b. It says in the book, guess, check, improve, but I don't want you to do that. I just want you to solve the questions algebraically. So 2x plus 3 equals 17. Subtract 3 from both sides in order to get the bit with x on its own. That gives you 2x equals 14. And I don't want to know what 2x's are. I want to know what 1x is on its own. So divide everything by 2, both sides, to get x equals 7. Here's another one. 33 minus 2x equals 19. Now whenever you see a minus, it belongs to the thing that follows it. So that minus belongs to the 2x, which is why I've kind of put a little bracket around it. So to make minus 2x disappear, we have to add 2x. And I'd kind of quite like the minus in front of the x, or the 2x, to disappear, because having minuses just makes things a little bit more messy. So to make the minus 2x disappear, I add 2x. So I do that and it's gone. But because I added 2x on the left, I have to add 2x on the right as well, because you have to do the same thing to both sides. So 33 equals 19 plus 2x. And I'd quite like to get the bit with the x on its own, so I'd like to get rid of the 19. So I take away 19 from both sides, and that disappears. But of course I've got to take away 19 from the left as well. So 33, take away 19, leaves you with 14. So I've got it down to 14 is equal to 2x, but I don't want to know what 2x's are. I'd like to know what x is on its own. So I divide everything by 2. I've got to do that on the left as well. So I end up with x is equal to 7. Okay, so there are some exercises there from the book to try. If you're watching this because you're on lockdown again, then you may not have the book accessible to you, but that's okay for now. Here's some more examples from that. X over 3 equals 2. So I don't want to know what x divided by 3 is. I want to know what a whole x is. So I multiply everything by 3. So multiply by 3, I get a whole x, but I've got to multiply the right-hand side by 3 as well. So I get x equals 6. Next one, x over 2, or x divided by 2, is 6. I want a whole x, so I need to multiply everything by 2. And then I get a whole x is equal to 12, having multiplied both sides by 2. Here's another couple. B minus 17 equals minus 4. I'd like to get rid of the minus 17 to get the b on its own, so I have to add 17 to both sides. So minus 4 adding 17 gives you 13. So the answer is B equals 13 after I've added 17 to both sides. Okay, the next one, 4x plus 3 equals minus 5. I've kind of done a sketch there when I've done this in class of 4 unknown bags of stuff, jelly beans or whatever, to represent my 4x, and then plus 3 loose jelly beans, M&Ms, whatever they are. So that's what that little sketch is. Anyway, 4x plus 3 equals minus 5. I'd like to get the x bit on its own, so I need to get rid of the 3. So I'm taking away 3. I have to do that both sides. So minus 5 take away 3 is minus 8. So having taken away 3 from both sides, I get 4x equals minus 8. I don't want to know what 4x's are. I want to know what 1x is on its own. So I divide everything by 4 to get a single x. And then doing that both sides, I get x is equal to minus 2. Here's another one. N divided by minus 4 equals minus 2. I don't want n divided by something. I want a whole n. So I need to multiply it by the minus 4 to make the fraction disappear. So if I multiply by the minus 4 in the fraction, I get a whole n. But I've got to do the same thing to the other side as well. So minus 2 multiplied by minus 4 gives me plus 8. So n equals 8 in that case, having multiplied both sides by minus 4. D over 4 equals 11. I don't want to know what d over 4 is. I want to know what a whole d is. So I multiply everything by 4 to get a whole d. But because an equation is like a balance, I need to do the same thing left and right. So 11 times 4 gives me 44, and d equals 44 is the answer. 2f equals minus 10. Divide everything by 2 to get f equals minus 5. And here's some questions and answers from page 186. So 2x minus 3 equals 7. Add 3 to both sides to get the bit with x on its own. Then you get 2x equals 10. But I don't want to know what 2x's are. I just want to know what a single x is. So I divide everything by 2, left and right, to get x equals 5. Next one, 3x plus 5 equals 8. Take away the 5 to get the bit with x on its own. So I get 3x equals 3. And then to get a single x, divide everything by 3, and you get x equals 1. There's another one there. I'm not going to go through the whole explanation. You can pause the screen and look at it yourself. It's the same sort of logic as the previous examples. You can always ask me if you don't understand it. And there's yet another couple of examples from the book. Again, pause the screen, copy, make sure you understand, ask me if you don't. Further examples from that exercise in the book, pause the screen, take notes, ask if you don't understand. Another one with brackets, 3 brackets x minus 1 equals 12. When you see a bracket in front of a number, it means multiply the number by everything in the bracket. So 3 brackets x minus 1 means 3 times everything in those brackets. So 3 times x gives you 3x. 3 times minus 1 gives you minus 3. So 3 brackets x minus 1 equals 12 is the same as saying 3x minus 3 equals 12. And then I've just gone on to add 3 to both sides and divide everything by 3 to solve that and get x equals 5. Another example, again, you can pause the screen, copy. If you don't understand, do ask me. And that's the end of chapter 1.